In part 2, we're going to work example 2. I forgot to label it. There it is, example 2. Example 2 asks us to plot each of the 3 points to form the triangle ABC. Then we're going to verify the triangle is a right triangle. Okay. So they gave me 3 points, an A point, a B point, and a C point. Let's go plot those on the grid. So we have -6, 3. So -6, 1, 2, 3, 4, 5, 6, +3. That's right there. I'm going to label that as point A. I have point B that's at 3, -5. So 3, -5 is down here. That's B. And then finally C is at -1, 5. 5, which is up. And then we'll connect them into a triangle. And there's our triangle. Now what we have to do is verify that that triangle is a right triangle. And without knowing anything about the angles, the only thing we can do is the back-grade theorem. So we need to come in and find the lengths of each of those sides. And sure enough, those side lengths are the distances between each pair of points. We have to find all 3 of them. So the first thing we're going to do is let's go find the distance. And I'm going to label that as AB as subscripts. And that reminds me that I'm finding the distance between side or point A and point B. So that's this side over here. So we're going to plug into our wonderful distance formula, which says x2. I'm going to use the 3 as my second point, minus x1, which is the -6. So this is this x minus this x, quantity squared, plus the change in the y's. So that would be -5 minus 3 squared. So cleaning that up, we have 3 plus 6, which is 9, and we'll square it in the next step. -5 and -3 is a -8, which is the -8 squared. So 9 squared is 81. 8 squared is 64. And if I add those together, I'm going to get the square root of 145. And we talked about having to clean up those radicals. So let's go ahead and clean up that specific radical. So 145 will obviously divide by 5. So it's 5 times. That's terrible, isn't it? Trying to prove a point. I can't because I don't remember it. Okay. So 145 divided by 5 comes out to be 29. And I'm done because there is no square in either 5 or 29. 29 is prime, 5 is prime. I can't simplify it. Square root of 145 is it. So didn't get very far with that. Okay, so we now know that this side of the triangle is the square root of 145. I'm going to label it because I'm going to need room on the board. Okay, now we're going to go find the distance from, let's do B to C next. So B to C. So again, I'll treat the second one written as the second point. So we'll have -1 minus 3, quantity squared, and then 5 minus a minus 5. So that's going to give us a -4, which we're going to have to square. It's going to give us a +10, which we're going to have to square. So 4 squared is 16, 10 squared is 100. And again, -4 times -4 is a +16. It's going to give me the square root of 116. Okay, this one we can simplify. So 116 is even. It'll obviously divide by 2. So it's 2 times 58. 58 is even, so it will divide by 2 again. So that's 2 times 2 times 29. And because I have a pair of 2's, I know I can simplify this into 2 times the square root of 29. So when you're taking square roots, you're looking for pairs of numbers that are the same that you can square root and pull out. So we know the next side is 2 times the square root of 29. Because of where we're headed with this to verify the right triangle, I'm actually going to use the square root of 116, but I wanted to see you simplifying a radical and show you how it's done. So our side length over here is the square root of 116. Okay, we have one more side to find, and that would be the side from A to C. And I know that's the one that's left because I've been labeling those sides over there. So let's go find the side length from A to C, that distance. So I'll use this as my second point. A is the first point. So we have -1 minus a minus 6, quantity squared, plus 5 minus 3, quantity squared. So that's -1 plus 6. That's going to give me 5, which goes. We're going to have 5 minus 3, which is 2, which we're going to square. So that's 25 plus 4, which is the square root of 29. And then it popped up a lot in our deliberations on this problem, which I kind of expect. Because because it's the right triangle. So, okay, we now have the three side lengths. Now we're going to go verify. So here's the verification. So we're going to verify that it is a right triangle. So in other words, a squared plus b squared should equal c squared. Now, the only one that matters is which side is c. C is always the longest side. So when I look at these radicals, which one has the biggest number inside? The largest number inside is at 1.5. That makes that the hypotenuse, which we kind of think anyway, because this kind of looks like the right angle. But just to be on the safe side, I don't want to make assumptions. So I'm going to take the square root of 29 and square it. I'm going to add that to the square root of 116, which we're going to square. And is that equal to the square root of 145 when we square it? And now you can see why I didn't bother really to simplify those radicals, because I knew I was going to get rid of the radical. So this gives me 29 plus 116 is equal to 145. And sure enough, that is true. So yes, indeed, it is the right triangle. Ooh, and now we have proof that it's a right triangle. So that was part A of the problem. Part B of the problem is asking us to find the area of this triangle. So now that we know it's a right triangle, let's go find its area. So we need the formula for the area of any triangle and the formula for the area of any triangle. And that is 1/2 the base times the height. So I just need the base and height. It's important to recognize that the base and height are always perpendicular to each other. They're always at a 90-degree angle. So what does that mean for this problem? Well, we've just established that this is the hypotenuse. That makes that the 90-degree angle. So one of these sides is the base, the other side is the height. It doesn't matter which one we use. So I'm going to do 1/2 times the square root of 29 times the square root of 116. So that gives me 1/2. And because we're multiplying radicals, you can multiply the stuff on the inside. So we just multiply the insides together. Again, avoid decimals unless it's an application problem. However, this one works out really, really nice. From our previous work, we know that 116 divides by 29 comes out to be 4 times 129. Sorry, 4 times 29. So on the inside of this radical, I have the original 29. 116 is 29 times 4, which is 2 times 2. So I have a pair of 29s and I have a pair of 2s. And that means everything comes out. I can simplify. I imagine that you're probably just going to take 29 times 116 and then take the square root. You'll get the same answer, but notice that I'm trying to do it by showing you how to simplify those radicals. So we have 1/2 times 29 times 2. Those 2's cancel, and I'm going to end up with 29, and that will be in square units. Because it's an area, I need some type of unit on it. We'll just call it square units. So there it is. We've now verified the right triangle and also found the area. Other types of problems that you'll see in the textbook that deal with the same kind of theory is the isosceles triangle problem. So verify it's an isosceles triangle. So a gentle reminder what isosceles means. Isosceles. Those words. I-O. Yeah. I-S-O-S. Forgot the second S. E-L-E-S triangle. And you're probably shouting at me in the video. It really means 2 sides are equal. So 2 sides lengths are the same. So when you do one of those, you just have to verify that 2 of the 3 side lengths are the same, and the 3rd side length is not the same. You will also see a similar problem with equilateral triangles. I'm sorry, involving equilateral triangles. Equilateral means equal sides. That means that all 3 sides are the same length. The same length. And all 3 of these kinds of problems are in your textbook, and you may be exposed to them.